In this video, I want to do another interest example. So this example is going to involve a few different concepts that we've talked about from this section, and it's going to be a multi-step problem. So that's just something to be aware of as we get into this. It might make it a little bit more challenging, but as we work through it, I think that it won't be too bad. So the example is, you invest $16,000 in a bank earning 4% interest compounded quarterly. A friend invests $6,000 in stock at 9% rate compounded continuously. After how much time will the investments have the same value? So question mark there. Okay, so one thing I should mention is it's implied that these two investments are made at the same time. So when you invest the $16,000 in a bank is the same time that the friend is investing the $6,000 in the stock. So pause the video at this point for 4 minutes and try this question. 4, 3, 2, 1, pause the video. Pause the video for 4 minutes and really try this problem. This is a really good practice problem that gives you a chance to practice how well you're able to integrate the concepts that we've talked about over the previous video. All right, so let's go ahead and start to talk about it together. So one thing that it says is you are investing quarterly at a 4% interest rate. And it says that that amount needs to be equal to what the friend ends up with when they invest continuously at a 9% rate. And so let's figure out what both of these are going to be in general. So I have to take the initial amount that's in the investment. So for you, the quarterly rate, you were investing $16,000, and we multiply that by 1 plus the rate was 4%, so as a decimal that's 0.04, but divide it by how many times that interest compounds in a year. So quarterly means 4 times. So I divide it by 4. And in the exponent, I would have 4, so 4 times per year, and multiply it by t for the number of years. That's what my exponent would be. Okay, so that's the left-hand side. What about the continuously compounded rate on the right-hand side? Well, their initial investment was $6,000. That was the friends. And we multiply that by e to the rt. And r is 0.09 for them. And we have a t up there. All right, so we have this. So to simplify this, I could maybe divide both sides by the 6,000 and cancel out that number on the right-hand side. And 16,000 over 6,000, that's going to give us 16 over 6, which becomes 8/3. So we get 8/3, and then we're going to get 1.01 to the 4t on the left. On the right, we end up with e to the 0.09t. Okay, so we have this exponential equation. These bases, like the e and the 1.01, they're not common. So we probably can't tell the answer just by looking at this and just guessing what t would be. When we can't get a common base, we need to use logs. So what we can do with this now is we can take the log of both sides. So let's take I'm actually going to take ln of both sides, because ln and having this e here will actually simplify very nicely. But I could actually take log any base and have it work. So on this side I get 8/3 times 1.01 to the 4t inside the ln. On the right-hand side, I get ln of e to the 0.09t. And now I want to do a brief review of some log properties, because there are a few log properties that are going to help us here. But let's just do a general review. So the first is, if you have log base b of something times something, of x times y, that equals log base b of x plus, actually let me give myself more room here. All right, so I just moved everything over to the left a little bit. So I have log base b of x plus log base b of y. That's one log property. Another one is if you have log base b, and then you divide two things inside the log, x over y, then you end up subtracting the logs. You get log base b of x minus log base b of y. Two more. If you have log base b of a to the c power, the power comes in front, and you get c times log base b of a. And the fourth one that I'm going to write is if you have log base b of b to the c power, this ends up equaling c. Okay, so we have these log properties. So I'm going to use some of them for our problem. So on the left-hand side, inside the parentheses, we have this 8/3 being multiplied by 1.01 to the 4t. So I'm going to use property 1, where we have the x and the y being multiplied, to split it into two logs being added together. So that gives me ln of 8/3 plus ln of 1.01 to the 4t. You might ask, wait, on the left-hand side, I have this power. Couldn't I just use property 3 to bring that power, the 4t, to the front? And the answer is no, we actually can't do that, because 4t isn't the power of everything on the inside. 4t is only the power of 1.01, and in property 3, c, this exponent, it's the power of everything inside the log. It was the power of the whole a, but it isn't in my problem. That's why I need to use a different log property to try to simplify this. The other reason why taking logs of both sides, even in the previous step, was good is because taking logs helps me get a variable out of an exponent. Okay, so for example, on the right-hand side, ln is log base e. So I can use property 4 on the right-hand side, because the base of the log and the base of the power are the same. They're both e. So what we'll end up with is 0.09t, and that's kind of nice. At least the exponent's out of, the variable is not in the exponent anymore over there. So let's leave ln of 8/3 as is. Now, with the next term, 4t is the power of everything inside the log. So I can move it to the front. Now I can move it to the front, and we'll get plus 4t times ln of 1.01 equals 0.09t. All right, so it's looking better. We got the variables out of the exponent. So now let's get everything with a t on one side. So we have ln of 8/3 on the left. Let's move 4t times this ln term, subtract it over to the right. So I'll get 0.09t minus 4t times ln of 1.01. All right, so we got ln of 8/3 on the left. And now on the right, both of my terms have this t in common. So we can factor that out. And when we factor it out, we will be left with, from the first term, I'm left with 0.09. From the next term, I'm left with minus 4 times ln of 1.01. Okay, so now I just need to divide by this whole thing that's in the parentheses to isolate t. So t is ln of 8/3 all divided by 0.09 minus 4 times ln of 1.01. And that's what t is. Well, okay, so we have t, and that's what it wanted us to get, the time. How much time would it take? And because there was no time unit sort of given in the problem, remember, I've said before that that means the convention is the time is in years. So this is in years. So if I wasn't allowed to use a calculator, I could stop and leave my answer here. I'm also just going to plug this into a calculator to get a feel for how big is this. It turns out this is 19.53895 years. That's how long it would take for the friend's investment and your investment to end up being the same. We've finished now goal 3. We have ended by doing this more challenging interest example where we really had to incorporate a lot of our knowledge about logs, and even do some review about log properties that we may not have seen in a while.